Networking, Security, and Wireshark.
So the last video I did on smuggling data with ping was a great success. I got a ton of feedback from users. One of the primary pieces of feedback I got was that many of you aren't familiar with Linux or as familiar as you'd like to be. And so I wanted to make a version of this that actually used a Windows PC in order to exfiltrate data to a remote receiver. Okay. So again, just for a quick reminder, exfiltration of data means to get data from a PC within a secure environment. So on the left-hand side here, we have, say it's a a secure network. I'm just going to SEC to a receiver outside of that network, and we're going to show you how using ping. Now, a few of you asked, why would we even do this if you can just send traffic through the firewall normally to an internet site and post data? Well, the answer to that is many organizations don't allow end user PCs to communicate directly with the internet. Many organizations employ what is known as a proxy server. Okay, so there's a lot of complication to proxies, but to keep it simple, what a proxy server is effectively like a man in the middle to carry internet-bound traffic to the internet. So if you're on a PC and you need to surf the internet or make any sort of call to a server on the outside, you would send that first, or your PC would be configured through policy to send that first to the proxy server. And the proxy server would then send that request out to the server on the outside. Now, what that does is when you do that, it's recording what websites you go to. It's recording your username, right? And you also have some advanced implementations where the proxy also will decrypt SSL and do some. That allows you to, even if you're doing an HTTPS call, like a secure website, the proxy may have the capability of decrypting that and actually inspecting the contents of your traffic. Maybe keep some organizations I've seen will actually store all the contents of the web traffic in archives. So in case there's an investigation later, they can take a look at it. And then those same organizations will block the user PC from actually being able to get out that same firewall. Okay. So really, if you're trying to exfiltrate data, you have no option other than to go through the proxy server to get to the outside, in which case your data is actually going to be inspected. So that's a no-go. And that's why malicious actors, or even, again, freedom fighters, look for ways to actually get around these controls and send data out outside of the proxy channel. Okay, so really what you're looking for is a method to send data through the work firewall, through the internet to the remote side, when things like HTTP are usually blocked. Okay, usually they're blocked. So that's where, if for whatever reason, the person who configured this policy said, okay, well, we're going to block web requests, but we're still going to allow ping. Okay, we're going to allow ping. And there's lots of reasons to allow ping. Like, I mean, a few of you also commented that, ICMP is used for lots of different reasons, and there's good reasons to use ping. Path MTU discovery is used, it needs ping to operate, so you need that for certain devices. All that is totally true. But you should never let actual NPCs communicate using ping to the outside. If you have like a certain device, right, that needs to use ICMP to communicate to the outside world for a very important reason, your firewall policy should only permit that device out, right? It shouldn't just let everyone who has an asset on the network communicate via ping. And why is because ping, again, can carry data. And that's what we're going to show you today. So that's the theory. We want to find a way to get traffic from this PC out through the firewall to the internet to the remote side without it going through any sort of proxy or security services. And if by chance your work firewall or corporate firewall, government firewall has ping enabled, then that is one method of doing that. So I started the video last time with a quick test that people could do. And the test was really this, is start from your PC in that environment, if you have a PC in an environment you want to test, and just try to ping to Google, ping 8888. And if this is successful, that means that this exfiltration method will potentially work. Okay, so that's the theory. Let's switch into this, how we're actually going to be encoding the data in pings this time, because it's a little bit different than last time. And then we'll also show you the scripts and then how it all works. So I fired up Wireshark. On my Ethernet adapter, I'm just going to use ICMP. I'm going to hit enter. And I'm going to do something very simple. I'm just going to, again, ping Google. And there are my packets. Now, what we did last time, remember I mentioned that in the ICMP echo request packet, right, there is a field, if you open it up in Wireshark, that is for data. Okay. Now, what the operating system, this data fields here is because you want to be able to have pings of different sizes. When you're using ping to do things like test out links, link capacity, you want to be able to vary the size of these packets up and down so that you can assess really like how the link does at higher packet sizes, right? So that's why this field is here. What Windows will do is feed random data into this field up to the length that you specify in the command. So you can specify a length in the command that is 100 bytes, 1,000 bytes, 1,200 bytes, and then Windows will fill out this field with the appropriate length of data. Now, in the previous video, what we did was we actually used Linux to manually put data into this field of our choosing. So we took a text file, we split it into pieces, we put each chunk into the data field, and we sent it that way, and then the receiver got it and can actually take all those data chunks out and put together a text message on their end. Windows doesn't permit you, through the default native tool ping installed in command prompt, to change what is in the data field. It only allows you to specify the length of the data field, okay, which poses a problem if you want to exfiltrate data because, that's a very easy way of doing it. So what we're going to do instead in Windows, okay, instead of actually modifying the contents of the field, what we're going to do is take this field up and down in terms of length. We're going to map the length of the data field. You can see here the length in this case is 32. We're going to map the length of the data field to a specific character in ASCII. And then from there, we're going to use the encoder encode each character as a certain length, and the decoder will decode with that length on the other side. Now, the drawback to this method is that, as you can imagine, you can only encode so much data every time. Like every packet represents just 1 byte of data, which is a very, very low rate of data transfer. And we'll calculate the data transfer rate in a sec. However, if you think about our scenario, like if you're in a case where, if there's a malicious actor doing this, they may have this set up and running for days, weeks. There was a company, a movie company, if you know what it is, if you're talking about, post it in the comments. But there was a company out in California, I want to say it was Universal, that lost a bunch of data. It was exfiltrated from their network. And the attack went on for months. Like they had an asset within the network, and for months it was sending data out to a third party. Now, if that's the case, this attack kind of fits because really, if you don't really care about how long it takes, you just want to get the data out and do it quietly with a very, very low rate of transfer, then this method works perfectly. Okay. And again, it also works on Windows because the Windows ping tool allows you to modify the length of the data. It just doesn't allow you modify the data itself. So we're going to ignore what's in the data packet. Our script is only going to look at the length of the data packet, and we're going to map that to ASCII characters. So let's get to the script. So the tool we're going to be using for this is called PPing. It's a very, very simple PowerShell script that I wrote and posted to GitHub. I will post the link to this in the description. The usage is very simple. I'll go through it just briefly. What you do, there's a few files. There is a psping file. I was supposed to rename that, but it's psping. And there's also a decode file. So the psping PowerShell script will take the contents of a message text file. So in this case, I've just got message.txt, and you have a destination IP inserted. And then it will start breaking that message down character by character, encode each character you can see here into an ASCII value. If you're not aware of what ASCII is, it's basically a set of characters available or a standard for encoding characters using binary values. So each character in ASCII has an associated value. So what's happening in the script is that for each character, it's finding the ASCII value. We're adding 128 because we can't really have packet size 0 being a value used by ping. So we just kind of bump it up by 128. And then you can see here the actual ping command that you use in Windows. So ping, destination IP, N1, W1. So we're only doing one ping at a time. And then the length of the ping is going to be the packet size. And the packet size is going to be determined by what character you're trying to send. So that's this script. The other script, how do I get this back, is the decoder, which requires you to actually capture the file in the format of a PCAP or a packet capture. So I'll show you how to do that. I'm actually going to use TCP dump this time, show you something a little bit different. And then it'll spit out a decoded message. So by the end of this, we're going to tell whether or not this actually worked by validating that the message that we sent is the same one that we received. Now, if you're not familiar with, or if you are familiar with GitHub and Git, then what you can do is just clone this repo to a local folder and run these files. If you aren't, you could just either save these files. There's a way you can just download the raw file and then put this into a folder, or just copy and paste these files into a text file and then save it as PS1 extension. Okay, so let's fast forward. Let's get the file set up. Let's get the capture set up on the remote end, and then we'll show you the attack. So back to our scenario. The Windows PC on the left here is where I'm going to run the PowerShell scripts as Mr. Freedom Fighter. The remote receiver. In this case, I'm just simulating this with a server in my own network. This could be a server on a remote network. It doesn't matter. As long as ping can get to it, you can get the data to that server. And the IP is 10.0.10.150. Now, when I'm receiving the packets over here, I'm actually going to be using TCP dump this time. I'm going to show you how that works. Dump. So let's move over to and set up the capture on this end. So I have a terminal to that server, 10.0.10.150. And I'm going to use TCP dump. I don't have a video yet on TCP dump. I will do one sometime soon. But TCP dump is a Linux-based capture utility, similar to how you can capture in Wireshark using the GUI. You can use a CLI to capture in TCP dump. And TCP dump is really useful because it works on a ton of platforms. So say, for example, you actually have the IPings going to a server in this scenario. You can do it on a Linux server. Say the pings were going and hitting like a firewall that you had access to. A lot of firewalls have TCP dump built in. So it's good utility to learn. So let's just set up the capture here. The syntax is TCP dump /i for interface. The interface on this is ENP2SO. That's the LAN interface that the traffic's going to be entering. I'm going to do ICMP, so the filter for the actual traffic, ICMP, and host 0.10.43. That's the source of the traffic on the Windows machine. Now, by default, TCP dump will output everything to the console, meaning it'll just show you the data and not save it. And I want to do this for a specific reason. I want to do this so I can test whether or not this machine is actually getting it, the traffic. Now, usually by just pinging something, if you get a reply, you know that it's getting there. But just to double check, 10.10.150, you can see as I'm pinging it from my Windows machine that I'm getting the traffic. So that's all good. Now what I want to do is just clear my screen. I'm going to set the same thing up, but I'm going to add some additional commands. So I'm going to do a write command, -W. I'm going to say this is going to be secret PCAP. And I'm going to do a verbose command so that I can see how many packets are captured. This write command will stop outputting to the console, so you're not going to be able to see as the packets come in, but the verbose command will tell you how many packets you received, so you can kind of confirm that way. Now let's do that. So we got 0. That's good because we haven't done anything yet on our side. So the next thing I'm going to do is fire up PowerShell. And I'm going to just move this around, and I'm going to go to the folder where I have this script. So my machine, and again, this is the Windows machine I'm doing this on. The scripts, think it's PPing, yeah. And just like on the GitHub, I have the same files, right? I have a message.txt, I have psping, and I have decode, a readme, and then I also have a sample capture here. If you want to just try this without actually doing the encode, you can actually try the decoder on this capture file, but I'll show you the decode after. If you're curious what's in the message, I was talking to ChatGPT about some ICMP protocol stuff, and I have a little line of text here that I'm going to use as the sample message. So the hope is that this message gets to the destination at a reasonable time. All right, so we've got this side set to send. We have the receiver set to receive. I want to do one more thing here because I want to show you some tricks in Wireshark. Wireshark, I'm going to start a new capture. And I'm going to do it on the Ethernet interface again. I'm also going to do ICMP. I'm going to do and host 10.0.10.1.10.150. Remember, I'm on the Windows machine here, so my IP that I'm filtering is going to be the opposite. It's going to be the IP of the server I'm sending data to. Beautiful. So my Wireshark is set. You don't need to have Wireshark to actually accomplish this, but I'm using it to show you something in terms of how much data is being transferred after the fact. So PowerShell is good. Remote end is good. Now, in order to run this, all you would do is from the PowerShell prompt, you would do a dot / and then psping. So as we mentioned before, this file is already picking up the parameters that we set. If you need to change the parameters at all, right, you can go and edit this file and change this to a different file name and this to a different IP, right? I already set these before to this server for this demo, so it's all good. But make sure the message file is in the same folder and make sure the IP address is correct. And we are just going to run psping one. Now, you can see, first of all, what's happening is all of these are ping commands that are running through in rapid fire. We're sending one ping at a time, each one with a different character with a different size. I go to the server, I can see here, I all of a sudden start getting traffic. That's awesome. And what I want to show you as well, once this is done, or I'll let it while this is going, actually, I'll show you. You can see in Wireshark, we see the traffic as well. And if you notice, the length of all these packets, so the ones that are coming from me are 43, 43, 43. The length is varying. So we're again, this is the encoding scheme that we came up with. Think about like when you were a kid and you used like a secret code to send like messages to your friends. This is the same thing, right? We are modifying this length up and down to correspond to different ASCII characters. Now, something else you can do, if we talked about rate of transfer, each of these packets is encoding one character, right? And that is 8 bits of data or 1 byte to represent one character, okay? So you have basically 1 byte per packet. Now, how many packets are we sending per second? Because we want to calculate the throughput. So if I go to IO graphs, and I have a filter here on my IO graph, IP source is 10.0.10.43. That's just me. And you can see here, these are all my ping packets. In Wireshark, what you can do is actually set the, let's move this up a bit, set the y-axis to packets, because I want to know how many packets are being sent out at a given second. So it looks as though, through the script is done now, we're kind of averaging around 17 packets per second. Okay? So if you think about that in terms of rate, right? I'll go back to my drawing board. So I have 17 packets per second, and then I have times 1 byte per packet. Those cancel. Is 17 bytes. A whopping 17 bytes a second of transfer. And again, this is not supposed to be high. This is minuscule. But it's just to demonstrate how much data we're actually getting out of the network. You can use this to kind of calculate how long it would take to do certain files. But in total, that message took, looks like around 25 seconds to send, which in this day and age is horrible. But Again, this is for scenarios where you're not really concerned about the amount of time. So we have the data. Let's go back to our server. We got all the packets through. It said it captured 914 packets. Let's see how much Wireshark recorded, just to make sure we're pretty much, should be the same. 914, perfect. So Wireshark on my machine says 914. On the receiving end, they also got 914. For some reason, Mozilla opened. Let's go and see if we can decode this message. So I'm going to open up the Linux server. Now my Linux terminal has a little browser here that can show me the files. So I'm going to refresh this. And I said it was secret.pcap. Okay, so what I'm going to do with secret.pcap is I'm going to download this file. I'm going to put it in my scripts folder under PPing. Okay. And let's go back to terminal. Let's do a list. You can see here I now have secret.pcap. And in order to decode it, let's do a quick look at the decode file, decode ps1. So this file, one of the things that you do need in order for this to work is to have Wireshark installed on this machine. I already have Wireshark installed. And again, that's why I was showing you the demo. But you can see here, it does require you to have T-Shark, which is one of the applications that comes with Wireshark. So if you've got Wireshark installed, you'll have T-Shark. You can see here the filter used in T-Shark. What this is doing is basically using T-Shark to go through the file, the PCAP file, and pull out all the lengths of the data field. Remember we talked about the data field is the length that's going to go up and down. This variable contains all the lengths, and then this piece of code here goes through and converts those to ASCII characters and then puts it into a file. So let's pull it all together, and we're going to do what's it called again? Decode. And it says decoded message saved to decoded message.txt. So let's go look. Cat decode. And now the true measure of success, decoded, yeah, is going to be whether or not this is accurate compared to the original. So let's look at the decoded message. And let's look at the original message. And a quick eye check would tell me that they're the same. Isn't that pretty cool? So this server, I'm going to just back this all up. This server on my PC and the remote receiver could be any two devices across a local network, a corporate network, or the internet. Anywhere in the world. As long as you could ping it from here to here, you can get that message across, even if all of the other policies block you from sending traffic. Now, there's a few caveats to this that we have to cover, and some of you are probably going to comment about it, which is totally valid, and I think we should have that conversation. One is if there's any sort of packet loss between here and here, pieces of your message may be dropped, right? So certain characters may get dropped. So an extension to this script may be to add some kind of reliability into it, just like we have in TCP. That's totally possible if you just spent enough time to actually modify the script and test it. That's one. The other one is that you may have packets arrive in the wrong order on the remote receiver. Sometimes when you have a very, very long links, like say this is over in APAC, Asia Pacific, and we have a sender in the US, sometimes what can happen is packets can arrive at a receiver out of order. Like one of them happens to take one path here and the other one takes a path here, and this one's a little bit slower, so the packet gets here in the wrong order. Same thing is that you could, in theory, modify the script you have to accommodate for the fact that things come out of order. You could do things like use another one of the fields in the packet, like say, for example, the type field, or another one of these fields to indicate the order of the packet, right? Like this is packet 1, this is packet 2, this is packet 3. ICMP has these already built into it. We just can't modify these in Windows to be able to use that if we're exfiltrating. So, but totally possible in theory. So those are some concerns. And again, it's not a foolproof method, but it is pretty cool. right? That you could secretly get a message through. I can tell you that there's not a corporate security appliance vendor that I know of that is going to be reading ping packets for their length and then associating that with ASCII characters and then figuring out that you're actually sending a secret message through. That just doesn't happen, right? There could be vendors like security firewall vendors that look at the content of ping packets. I haven't, in my professional experience, found one that can actually do that and actually look at the contents. But if there is one, then then this method, because you're using a custom scheme to change the length, is not going to get detected. So the only real protection for this, if you are on the other side of this coin, if you're the actual administrator of this network and you want to keep it safe, is restrict ping, right? Don't let end users ping through your firewall or to anything outside. Any traffic that the end user has to send to anywhere outside of your security perimeter has to go through some kind of secure monitoring where you can ensure what's happening in that traffic and you could validate it. If a device on the network, say this is a switch, needs to use ping or ICMP on the internet, you permit just that device or a set of devices based on their source IP to access the internet. You do not let end users communicate through your firewall with protocols that you can't inspect. And the way that people usually do that is through proxy services. That's it for this video. If you enjoyed it, please like and subscribe. And if you have any questions on the topic we've covered, please join the Discord server where we talk all things network. Until next time.